Well, hello again. Today I'm going to be talking about the basics of information technology. All right, so what we're going to learn today is we're going to learn the basics of what you need to know to be able to understand when people say stuff to you about IT, to be able to communicate clearly, to be able to know what you're looking at when you read a specification, to just really all around get what IT is. Now, the basics of IT. A couple things that we're going to just have to understand right off the bat. Okay, local area networks. Local area network is a misleading name. Local area network could span multiple buildings. It could be on a single floor. Okay, the key point of a local area network is it stays inside. That's the typical defining aspect. It stays inside that corporation. So, for example, what do I mean? Well, let's say you had four branches, you had four office buildings, you had a campus with four industrial facilities, and you had a local area network. Okay, well, what that would mean is those facilities are all connected and they're connected via the company's network. It's not using the internet. Now, when you move to a wide area network or WAN, so if you ever see WAN, that stands for wide area network, you move to that, the easiest way to define a WAN is that you have to go through the internet to get to the other local area network. So WANs connect LANs. So it'd go LAN, WAN, LAN. Now, that's not a hard, fast rule. You'll learn nothing in IT, just like nothing in HVAC, is a hard and fast rule. But it's the 95% of the time, this is what it is, and let's focus on that 95% of the time. So you go local area network, you go WAN, and then you go LAN. All right. So what's next? So we've went over the LAN, WAN, LAN. Let's first talk devices. So you'll often hear a couple different things. You'll hear of a client, all right? So you hear client. You will hear of a server, and we'll lay all this out right here as we go. So here's your client, and you'll hear of a server. So let's lay this out. Let's just call it server. You'll hear of a network. Sometimes you'll hear it called a level 2 network. Sometimes you'll hear it called a level 3 network, but you'll hear of a network, right? Typically, these things are called devices that are on the network. So a client PC, a client laptop, that is a device. A server is a device. Now, what is a server? Well, think Internet Explorer is going to need a web server to host a website. You'll need an email server to host your email. Various things are done by servers. Now, there's two flavors of servers. There's the typical hardware server and the virtual server. Okay, so a hardware server, this is going to look like a virtual server, or sorry, it's going to look like a rack mount or PC server, typically. So what would it look like? It would look like a regular desktop PC that's sitting in someone's office. That's bad. Ideally, it would look like a rack mount server. Then you may have heard these called edge servers. You may hear them called blade servers, power edge. Just depends on the model, depends what you're doing. Blade servers are typically thinner than rack mount servers. Now, what you're going to do is a rack mount server. It's going to have a server OS. It's going to run whatever an OS is operating system. It's going to run whatever application it's running, and then your clients are going to connect to the server, and they're going to say, "Hey, I need information from this application that you're running." Now, that may look like they, in some cases, like email, where they actually have the application right there on the client PC. So, email. And they have an email client. It goes up to the server that also has an email database. And what it's going to say is it's going to say, "Hey, send me my email." It's going to say, "Here's my email that needs to go out." The server's going to say, "Oh, okay, great. I'm going to go and send your email out. And what it's going to do is it's then going to connect to its router. It's going to connect to its router right over here. And let's use a thicker line here. It's going to connect to its router, and then that router is going to go to its serial connection, and it's going to send it right out to the wonderful world of the internet. Okay, and then when it gets email back in, we're going to call this the internet. When that email comes back in, it comes through the router. Okay, so we'll just call this a router. It's going to come through the router, back into the server, to the email. The email is then going to get sent down to the clients. Now this is all happening on a local area network. This could happen on a wide area network. For example, your email server may be here at corporate, and you've got to go, your client goes through the router, authenticates with the email server, and it gets sent back through the router to your client. Now, this is very basic and generic. I haven't focused on building automation yet. The key point I'm trying to get across here is just what a client, a server is, how the router's communicating, it's using an input, output to the internet, going and then going to another local area network. So this is your LAN, this is your WAN, and then you've got another LAN here. Okay? Now there's multiple technologies that you can use to get to the internet from a router. We're not going to go into that. We're not going to talk about really the multiple technologies you can use for local area network. We're going to focus primarily on Ethernet. We're going to focus on what a subnet is. We're going to focus on what IP is. Okay? We're going to go through these different things. Alright, so I know I'm repeating myself here, but I just really want to hammer this down. Client. This could look like a thin client. Okay? Which just runs a really light version. An example would be a control system that uses Java. That's a thin client. Because the entire operating system, the entire OS for that application is not running on that PC. It's just opening a Java application and grabbing data from the actual server. Whereas a thick client, right? Thick client is going to have everything actually stored on the local client. Okay, that's a thick client versus a thin client. Now there's other ways to define it, but for what we're doing, that's going to be the clearest way to define it. Alright, so let's clear this out here. Let's open up a new one. Okay, so we talked about local area networks, WANs, clients, and servers. Now let's talk about what does this mean for building automation. Let's say you get a spec and it says client has an existing backnet system. We're just going to call this backnet ABC system. And specification is going to say, all right, client has an existing backnet IP system. Approved bidders are A, X, and Z companies, and you must use a native backnet system to be interfaced with the existing backnet system. So what did we discover here? Well, there's a backnet system, right? 2, we got to be using open backnet. We'll get to what that means in a second. 3, we've got to be able to go and pull it in to the system. So we've got to pull it in to the existing system. Okay? So we've got that. So we go here, we lay our supervisory device, and we've got an MSTP trunk down here picking up our field devices. Okay? So we've got field devices here. Maybe we've got some controllers, and if you recall my backnet video, maybe there are some advanced controllers, okay? Maybe we've got just got a supervisory here, a BBC, got our advanced controllers down here, maybe we've got a unitary controller down here, okay? And what we're doing, so this is backnet over MSTP, this then comes up and it goes backnet IP, and now we have to connect this supervisor to this server. So what we have to do is we have to have an IP address. We have to have it on the same subnet, ideally. Not always, but ideally. You don't want to start messing with BBMIDs or BBMDs. So we do this. We've got our backnet IP. We've got it on our subnet. We've got our backnet BRUG building controller right here. It's going to our operator workstation or backnet IP server, and this is going over IP. Now, what's the difference between IP and Ethernet? Some people get confused and they think IP is a different kind of wire, when in actuality, IP is a protocol. Okay, IP is layer 3 or the network layer. Yes, it's getting a little busy here. And Ethernet is layer 2 or MAC address. Okay, so what's going to happen? This is going to have an IP address and it's going to have a MAC address. So what's going to happen here? Typically, there's going to be a switch. And this switch is going to have ports. A port is a connection via typically a Cat5 Ethernet wire, unshielded twisted pair. So if you see Cat5, category 5, UTP, unshielded twisted pair. So that wire then goes from this port to this port on the device. Okay, and then the switch has another port, and your backnet IP server has a port. So what's going to happen? All right, this guy is going to connect, and ideally, you're going to go and take a static IP with a subnet, and you're also going to have your default gateway. Your default gateway is where does this IP address go? That's typically your router that sits on this local area network. Sometimes your default gateway can be a switch. Sometimes it can be something else, but we're not going to get into that. All right. So first things that happen is this has a hard-coded MAC address. This is a hexadecimal address. If I were to go into my Internet Explorer and I were to look at that, you would see my MAC address, but I'm not going to do that right this second. I will do it a little bit later in this video. So your MAC address, all right, it's going to go out and it's going to send an address resolution protocol or ARP message. And it's going to say, hey, does anyone know this IP address? This is my address. And it's going to come out and it's going to go, and that is going to essentially be a broadcast message that is going to be all Fs. If you were to look at it at the layer 2 level, it'd be F, F, because remember, this will make complete sense when I show you what a MAC address looks like. So it's sending this data out and saying to the switch, and then the switch is going to send it out all ports except for the port it came in. So it's going to send it out this port, maybe it has a port here, it's going to send it out here, and maybe it's got a port here, it's going to send it out here. Initially. Eventually it's going to build a MAC address table and it's going to know where to send the data. But what's happening is that this is sending this information out, and then it's going and getting the information back, and it's saying, oh, by the way, here's this address. And it comes back. So the initial connection is via MAC address. Now we move into layer 3, which is IP. So when this device goes and it's got to send information to the backnet IP server up here, it's going to have the source IP of whatever this is. And now, because it got its information back, it's going to have the destination IP of right here. This source IP is going to know that it sends its MAC address. It's going to send it right to the switch, and the switch is going to know that the destination IP is this MAC address, and it's going to send that data here. And then it comes back, and that's how your connectivity happens. Wow, this slide got really busy. Did not realize I was letting it get that busy. Okay. So we saw our device. It goes on our local area network and goes to our IP server. We realize that we have a switch in between. that our MAC address transmit at layer 2, and then our IP addresses transmit at layer 3. Now that is all part of the OSI model, layer 1 through layer 7. Okay? When you're thinking of an OSI model, you work from the top down and then back from the bottom up, typically. Top being the application layer, the bottom being the physical layer. Okay, so right here, your physical medium would be this wire. It would communicate across the network via the level 2, which would be your MAC address, which then goes into an IP and so forth. I'll go through the MAC address or the OSI in greater detail in a different video. But right now, you should have the basic fundamentals down. Okay, so we set up our BACnet BBC, right? We know it supports BACnet IP because we checked out our pick sheet. And by the way, if it's a BBC, it typically supports BACnet IP anyways. But we know it does, and we go and set it up. We have an open BACnet system because we're using somebody who adheres to the BTL listing for a BACnet IP server. And all we have to do is log into this BACnet IP server and discover this IP address and discover the device instance, which is a unique BACnet object. We need to make sure that that's unique. We don't want to have conflicting device instances. And then we discover all the objects under it. So I would be able to discover my BACnet IP. I'd be able to discover all my MSTP field devices. And they would all seamlessly pull in here, and everyone would be happy. So that is BACnet. Now, it's fairly similar for LAN, it's fairly similar for Tritium, just different things are done at different levels. See, the BACnet framework uses it all here, and it's going to use a software/hardware translation. What it's going to do is it's going to convert MSTP, which typically is RS-485. It's going to come into the device and be converted to Ethernet, BACnet IP, come out here. It doesn't always have to be Ethernet, it can be fiber, whatever. Okay? Now, on a LAN system or a Tritium system, that may look a little different. For example, Tritium, let's say you got Jace here, right? And you have your API. And your API is connected to a RS-232 port, right? Let's say it's typical Modbus, RS-232. Some Modbus is 485. And you've got your registers, right? You've got your Modbus IDs and your registers are pulling the data. And that right here is coming in, and it's being converted in software from this to whatever protocol you want it to be. If it's staying internal to the Jace, it's typically converted to OBIX, or it's converted into just something that the API can read, like XML. Now, OBIX and XML, you don't need to know what they are. If you want to research them, they're right here. XML, or sometimes it's called SOAP over XML. Okay? But the key point is, different things do different translations, and that's why it's really important to talk to someone who understands the software, to be able to have someone who understands what all these different things mean. A lot of people get into this situation where they buy 3 different systems, System A, System B, System C, and they're all on an IP trunk, and they all have hardware devices coming off that. But then the person who specified it didn't really say, hey, you guys, you need to be smart about this. This system is allotted these device instances. It's allotted this IP address range. By the way, this is your naming scheme. Okay? You're going to use this kind of trunk. Maybe we're all specifying on MSTP, because maybe we're going to have 3 different systems, but we want to have whatever field controllers we want to have. Maybe we're going to standardize on the BBC. We're going to say it's all Apogee PXCs, or it's all Johnson Controls NAs. And then whatever the supervisory devices, don't really care. And whatever the field devices, don't really care. So this is your network layer. This is your field layer, field level network, whatever you want to call it. And this is your user interface or application layer. Okay? So you're starting to see a couple different things here, a bunch of different things as to what you can do with IT and why it's important to understand. So what did we cover here? As always, these are unscripted and kind of just on the fly, so they tend to be like a shotgun and just spread as my mind decides where to go. We covered local area networks. Okay? Covered wide area networks. We covered what a client and a server are. We covered what the difference is between IP, how MAC addresses route. We talked about how IP addresses, or MAC addresses, will be shared and how IP packets will be routed, rather. And we talked about the different devices, what a client, thin client, servers. We talked about engines. We talked about using routers to go through the internet, to go through and connect to another local area network. So you're seeing we got a bunch of different information here. I tried to cram it all in. What I'm going to do in my next video, I think what I'm going to do, is I'm really going to unpack setting up local area networks. You know what? No, I could probably do that real quickly. I got a little bit of time here. So if I were to open network and sharing, I were to go to change adapter settings, go here, properties, and you're going to notice I got IP4 and IP6. We're not going to go into 6 today. See the following IP address. I can set it. I can set my subnet mask, my default gateway, my domain naming server or service. And what this is going to tell me is if I type in google.com, it's going to translate it to the proper IP address. And there's a bunch of other things we can do. We can set up blocks of IP. I can set up multiple gateways. In case one gateway fails, I can go to another one. I can set up DNS, all sorts of things. Anyways, went through a lot here. And ideally, after going through this video, if you hear these terms, you'll understand what they're saying. My next video, debating whether I'm going to do local area networks or if I'm going to go through specifications and talk through how to read a spec. I'll probably do the latter. I'll probably talk through specifications. But once again, thanks for viewing, and I hope you've learned. Feel free to share your comments and provide me any feedback on my comments page. Thank you very much.